Welcome to class. The topic we have is function pointers, the general ones, and then we'll utilize them with structure in the upcoming lecture. The very first question is, can pointers point to a function? Yes, of course. Implementation is simple. If you pay attention, you would learn it. So, for example, we have a function called add. Add two numbers, number A and number B, for example. And what we do is we just return A plus B. Yeah, that's it. Now, what we do is we create a pointer to whenever we need to create a pointer to this function, we need to have exactly the same presentation, exactly the same prototype of the function. Let's copy it here. And when we need to create a pointer of this, we need to import this function name in brackets, for example, and we need to create a variable here, for example, function PTR, function pointer, and we have to put an asterisk here. So it creates a new function pointer of the same type most importantly, you don't add types, variable names here. Just the types are sufficient, as we used to do in functions chapter. We used to declare function prototypes first and then implement them. So whenever you create a function pointer, it should be just like the declaration. Now what we do is we say a function pointer is equal to add. And that's it. We're done. So let's try to compile this and run it. Okay, fine. It works. Now let's utilize this function pointer. How do we use it? Whenever a function pointer is being used, you do not use an asterisk before that, just like variables. For variables, you use an asterisk. But when using a function pointer, you just give it a call. And that's it. You say, okay, add 5 to 9 to variables, 5 to 9. The address has already been given to the function pointer. And function pointer, which actually is pointing to the add function, is going to give a call. Let's say the result in yes, and print it out. F and %D. Here we go. It compile and run the program. We'll see the result is 14. The add function has just been called. What is the purpose of doing that? Why can't we just give a call to add directly? Purpose of doing that is the pointer can change its location whenever you want it to. So what you can do is you can create a different function. For example, we are creating a calculator. For example, you say, okay, subtract. So later on, what you do is you and subtract. What does subtract do is it deducts this value, the second argument, from the first argument and returns back the value. Now, what we do is we just change the pointer. Just assign this variable on top so that we don't have a problem of redeclaration. Okay, so these were the three statements. Function pointer, we updated it with add. Then we called the function pointer and passed these values and printed the result. Let's add a /n here. And let's do it again. Duplicate this whole code by pressing Ctrl D. And this time we say we assign, to the function pointer, we assign the second function, address of the second function. So that whenever we call this, it's exactly the same as this statement. But this time, when the value of the function pointer is pointing to some other function, which is of the same type. Both are same. And we can just check the program. What does it do? Okay, -4. It says 5 minus 9 is -4. Maybe we can say, let's take some good values, which make sense. Okay, 5 and 5, the result should be 10. Of adding, in subtraction, 10 minus 5 should be 5. There you go. So What you have learned here is a function pointer can point to multiple functions at the same time. I mean, gradually in the program, whenever you needed to point it to a separate function, but its declaration would be exactly the same as of the function that you are pointing to, which in our case at the moment is add and subtract, these two functions. And these have exactly the same presentation. The return type is integer. Both of these, return type is integer. And in here as well, we have return type integer. The only difference that we have is when a function name is added, the pointer to the function is created, that should be encoded within these function brackets, the name of the pointer. And then there should be brackets around it and an asterisk. As long as the parameters, these parameters should not be defined with a variable name, rather only the data types. I hope it makes sense. If you have any question regarding this topic, let me know. We are jumping on to the function pointers, which are a bit complex than this one, but really easy. If you did understand this topic, it will be really easy for you to jump on to the next topic. Thank you.